100 years ago. The second died in the attempt. Survival here is a daily struggle. But now a huge structure is rising out of the ice. A science laboratory like no other on Earth.
For science, it's going to be absolutely phenomenal.
6 years in the making, we'll follow the last 3 years to the finish.
Every year's a battle. It's just a different battle.
The builders will face intense cold,
Steel seems to suck the temperature right out of you.
exhaustion, and once complete, a thorough inspection. For 10 days, the station will be examined, tested, and scrutinized.
This is the week that we truly don't sleep.
Because lives depend on this structure surviving the Antarctic winters.
I can't compromise, and there's only so much I can compromise.
Failure is not an option for the South Pole Superstation.
Let's get fired up, boys!
Antarctica. 14 million square kilometers of snow and ice. In winter, temperatures drop to minus 75 degrees Celsius and winds reach 200 miles an hour. Yet right here, builders are taking on nature by constructing one of the most advanced research centers in the world. One that'll help scientists reveal secrets about the planet's past as well as its future.
It's a little on the chilly side, I'll tell you that, but the quicker we get things done, the better we stay warm, I'll tell you that.
Since November 2000, a team of 100 builders have been taking on the elements to build a £78 million scientific research station. It'll be the centerpiece of a 15,000 square meter scientific village that, once complete, will be one of the most advanced facilities in the world and one of the most self-sufficient. With its own water treatment plant, advanced climate research center, a mobile drilling rig capable of reaching depths of over 1.5 miles, and a state-of-the-art telescope capable of searching for clues to the origins of the universe. 3 years into the project, one challenge remains: building the last 3 wings of the research station that will provide living quarters, offices, and even a sports hall for 150 workers. It's not just the Antarctic temperatures which make the task daunting. Exterior work can only be carried out for 110 days each year before the sun disappears for the winter. Completely cut off from the outside world, lives will depend on these buildings being able to survive the long months of winter darkness. So after the next 3 long years of back-breaking work, the structure will face an in-depth examination before it can be declared open.
We've been given a list of things to correct, and in the process of doing that, we found a few other things.
You gotta fix that ceiling.
10 days of grueling, painstaking inspections, known as Hell Week. November 2002. Work begins on the final 3 wings of the research station, raising the steel framework. It's the first stage of a building project that will last 3 years. 75 builders are working shifts to make the most of the Antarctic summer's 24 hours of daylight.
You don't want me welding over yonder?
Yeah, after you get the scaffold set up and get all the bolts and all the tools up.
340 tons of steel must go up over the next 2 summers.
Let's get fired up, boys! Woo! Come on!
The steel workers have the hardest job on the project, working with icy metal and exposed to freezing winds.
It's like nowhere else on the planet because the temperature gets to you.
Even the metal is affected by the cold. It shrinks unevenly in the sub-zero temperatures. Engineering finesse must be replaced with something a little more basic.
Banging on things with sledgehammers and make them fit, and it's kind of rough, and it's not fine finish work, I can tell you that.
And when a part doesn't fit or gets damaged, the nearest spare is literally on the other side of the world. Improvisation is key.
There's always a lot of plan B going on. A lot of cutting and welding, and we'll get a design from the engineers and just have to fabricate it here on site. whatever it takes to get it all done. We're not going to miss that schedule, is what we've been told, so.
The men in charge of the schedule are construction managers Carlton Walker and Jerry Marty. For them, starting work on the final stage of the project is a moment to savor.
We first started talking about this thing in 94, 95. We were drawing it on the back of napkins.
Out here, it's a full-time job.
We work together off-season, on-season, putting together the planning to make sure that all this steel and all these panels are here on time.
Meticulous organization is essential. The whole project requires 40,000 tons of construction materials and building equipment. All needs to be transported a distance of nearly 12,000 miles. And Jerry and Carlton get just one shipment a year. This far from civilization, any wrong or misordered part could cause delays running into millions of pounds. November 2004. The first flight of the season is about to land at the South Pole Station airfield. Each September, a freighter leaves Port Hueneme, California, and heads for Lyttelton, New Zealand. Once there, an icebreaker clears a channel for the ship to steam onto the largest port in the Antarctic, McMurdo. The unloaded freight is then transferred onto round-the-clock flights to complete the final 900-mile leg of the journey. Waiting for the flight are a team of cargo handlers. They need to be on the strip well in advance, prepared to unload the plane as soon as it lands. Operations manager Liesl Schöntenner has already been waiting 15 minutes.
When the planes come right after one another, you might be out here for 5 hours straight, right? You're working hard, but you're not doing a lot of moving around.
Fortunately, when it gets busy, cargo handlers have one of the most physical jobs at the pole.
When the planes get here, it's time to rock and roll, and that's what we do, we rock and roll. We have a lot of planes coming in today. They'll be coming in about 45 minutes apart with a lot of big, heavy, dumb stuff. You gotta really hustle to get that going.
There's a lot to do. Even though these Hercules LC-130s can carry a payload of 12 tons, the ground crew will still have to shift nearly 1,000 flight loads to keep the project on target and the builders equipped with the supplies they desperately need. And in the summer months, flights land 24 hours a day.
It's just totally cool to hop in a big rig like this and to move around stuff that, 100 people couldn't move by hand. It's awesome. I love it.
The builders have completed the steel framework of the Polar Station's final 3 wings. Now the team are starting to work on the next stage, attaching the insulated paneling. But there's a problem. A bulldozer and crane are not working. They're not broken, they're frozen. Without a crane, construction can't continue.
Yep. Right.
The nearest garage is 900 miles away, so every mechanical problem needs to be fixed on site. Mechanics have developed a specially designed gas heater to warm up frozen engines. Although it churns out enough heat to warm 5 houses, in this extreme cold, it's barely big enough to heat the engine above freezing. After several hours, the driver attempts to start the engine.
Very happy.
In the intense cold, even the simplest task is far from easy. But if it's so difficult, why build here at all? For the American National Science Foundation, who are funding this project, the answer is simple. They're convinced Antarctica holds the key to answering many of the big scientific questions affecting our planet. For astronomers, the pristine atmosphere and location at the Earth's axis gives them a perfect place to look for new stars. Physicists are hoping to find subatomic particles trapped in the permanent ice sheet. And the cold and remoteness is perfect for climatologists investigating our impact on the planet. Because of its ideal location, scientists have wanted to establish a permanent base here for over 50 years. The first expedition to reach the South Pole was led by Norwegian Roald Amundsen in 1911, followed a few months later by the ill-fated British explorer Captain Robert Scott. But the first attempt to build a station wasn't until October the 31st, 1956, when a US airplane landed at the pole for the first time. Within days, 24 Navy servicemen had constructed prefabricated huts out of canvas and wood. But snow quickly took its toll. After just 10 years, the station was engulfed by 10-meter drifts, forcing the Navy to brace their huts with extra supports. In 1970, construction began on a new center, an aluminium dome designed to withstand 200 miles per hour winds. The idea was that the snow would flow over the structure without settling. Named in honor of the first explorers 65 years earlier, the Amundsen Scott Station transformed the South Pole into a scientific hotspot. Filled to capacity almost from the day it opened, the research carried out has affected us all. It was here in 1986 that scientists first established the link between the hole in the ozone layer and man-made pollution. With a diameter of 50 meters and a height of 16 meters, the dome could provide 23 people with living quarters, laboratories, library, communications center, medical center, post office, and a general store. It even had its own pub.
Our only little bar at 90 South. It's got a little bit of character.
But although it looked high-tech, the dome was little more than a glorified tent sheltering prefabricated huts. Even a trip to the bathroom could mean walking through temperatures of minus 45 degrees. Built with 1970s technology and building codes, it's now hopelessly obsolete. And the dome had one even bigger flaw. Its smooth shape did not deflect snowdrifts. The only protruding object in a vast flat landscape, it acted as a windbreak, building up massive drifts that constantly threatened to crush it. Clearing snow became a never-ending and energy-intensive job, using 60,000 litres of fuel at a cost of £17,000 a year. With its replacement now half-built, the dome's interiors are finally being dismantled. 15-year veteran of the pole station, B.K. Grant, has mixed feelings.
Strange to get attached so much to a thing or a place, but without this, sure, there's a new station, and that will be a great thing. And for science, it's going to be absolutely phenomenal. I mean, the capabilities that we're going to provide they're just so far beyond anything down here, but this was home, and that'll probably be home for the next bunch.
The designers of the new center learned much from the failings of the dome, using the latest technology to tame the destructive power of the Antarctic snow. Their plan is to construct a station 8 times as big as the dome, and not on the ground, but in mid-air. The building will sit atop reinforced steel columns almost 4 meters high, allowing the snow to pass freely underneath and preventing drifts from building up and burying the station. The walls themselves are angled. Like aeroplane wings, they will force air passing beneath the station to increase in speed, blowing any settled snow away. And the structure will have another fail-safe mechanism to protect it from the elements. Although the Antarctic receives just 23 centimeters of snow each year, the designers knew that at these temperatures, it will never melt. So when the snow finally does reach the floor line of the new station, the building can be jacked up an additional 4 meters. And not just once, but twice. This innovation will give the new Amundsen Scott South Pole Station a lifespan of 45 years. But turning this revolutionary design into reality will test the mettle of the entire team. Midsummer 2004. With no nightfall, work continues through the 24 hours of daylight on the 3 wings. The new center will reduce its energy consumption by using heat-saving materials called SIPs, or structural insulated panels, in its walls, roofs and floors. Made of heat-stopping foam sandwiched between 2 layers of plywood, to obtain the same heat conservation in a normal house would require fiberglass nearly a meter thick.
All right, slide it in. Whoa. Wow!
There's a great deal to do, but keeping on schedule is no easy task in the punishing cold.
Steel seems to suck the temperature right out of you if you have to sit up there for long times.
Stay out here long enough, you get a free Antarctic nose job. Little here, little there. Gone, free of charge.
Frostbite is a constant threat for all the workers. Station veterans have found unusual ways to fend off the cold.
This is an old Alaska snow machiner's trick for avoiding frostbite, and that's duct tape. So you see people with duct tape from their cheeks across their noses all the way across to the other side. Decided to try it, it works great.
But the workers here are a tough breed. So tough, they can forget to come in out of the cold. To avoid frostbite, every 90 minutes they must take a compulsory break.
Break time!
At the pole, energy conservation is essential. Delivery costs make petrol 4 times more expensive than at home. A litre here costs over £4. So engineers have gone to extraordinary lengths to make sure that energy is squeezed out of every last drop of fuel. The station's power plant is now up and running. With 3 diesel-powered electric generators producing 1,000 kilowatt-hours of electricity, it's the most efficient energy system ever designed for these extreme conditions. The generators don't just produce energy, they also recycle excess heat, pumping it not out of the building, but into a system of sophisticated heat exchangers.
The whole station down here at South Pole is heated primarily off of the one generator that's running. We scavenge every bit of heat that we possibly can.
With the new generator up and running, other parts of the new structure now have power, including the recently constructed kitchens. This allows the workers and scientists to properly celebrate the major social event of the year for Americans, Thanksgiving.
Thanks, Stephen.
Thanksgiving to you too. Thank you, man.
For the first time, and in scenes which would astonish earlier inhabitants of the pole, cooks at the South Pole are hard at work in a true chef's kitchen.
It's pretty sweet. There's some really nice new toys that they gave us this year. Cheers. Cheers to South Pole.
Working hard in extreme temperatures, the body uses up huge amounts of energy. These workers eat as much as 5,000 calories a day, nearly 3,000 more than needed in a British climate.
We don't hold back on the butter, we don't hold back on the rich food. They like it filling, rich, and comforting.
I would say this is better than my mother's turkey, but she would probably kill me. So it's almost as good.
For project manager Jerry Marty, it's also a chance to thank his team for their hard work.
Happy Thanksgiving, and you're part of history.
And to celebrate their many accomplishments. In just 4 years, the team has already completed a new satellite dish, allowing communication with the outside world. They've erected a 7-mile-long antenna to help predict solar storms that could damage our wireless communication systems. But the biggest achievement yet is simply called IceCube. It's a probe scientists have developed that can detect subatomic particles called neutrinos found deep within the 2-mile-thick Antarctic ice.
They'll go at probably a rate of about 12 meters an hour, so we should be at 4 to 5 hours at 50 meters.
The ideal depth for the probe is over 1.5 miles. Using an ice-melting drill, it can take 48 hours to bore each hole. Once complete, the 5,000 sensors of the IceCube will be lowered deep into ice that froze millions of years ago, trapping neutrinos that could reveal how our planet and the cosmos has evolved. The data will open a window into some of the most perplexing events in our universe's past and future. Exploding stars, gamma-ray bursts, even black holes. Over the next 6 years, 80 holes will be bored over an area of half a square mile. So the rig and metal shelter is designed to move between locations. It's a massive undertaking, costing over £70 million, almost as much as the station itself. For construction manager Jerry Marty, every completed task gets him a little bit closer to the finish line.
IceCube, first hole, first string deployed, ASTO telescope removed, traverse equipment being offloaded, sock transition happening in another hour. Not a bad morning today for a Monday. How we doing?
It's a good day today, but Jerry now has just 1 season to finish the 3 new wings. They'll need more days like these to beat the freezing weather before they complete the project and face the final hurdle, the inspection team. November 2005. The team have now just 2 months to finish the final 3 wings of the Amundsen Scott Polar Station before the arrival of the building and safety inspectors known as the design team. Fail the inspection and the whole project will be put back a year, costing millions in delays. Last summer, the wings were complete enough for work to begin on the interiors during the 8 long months of the Antarctic winter. But there's still a lot to do.
Well, that's a tight fit.
They now have just 2 months to finish installing over a mile of heating and air conditioning system, put up 10,000 drywall panels, and complete over 60 miles of communication lines that will snake through the walls.
Take it apart, move it, put it back together again, right?
All of the work is managed by project managers Jerry Marty and Carlton Walker. With time so tight, teams work around the clock. This meeting started at 4:45 in the morning.
Did you guys get the plug-ins moved?
Isolated in the middle of 14 square kilometers of ice, Carlton knows that new workers can't simply be brought in if things fall behind. So planning is vital.
If everything else goes to the side, we move comms today. Top of the list.
But after 15 years at the pole, Carlton knows that in this environment, shortcuts are not an option.
There's no timeline or deadline that's worth getting hurt about, so that is the single thing to stress today. Let's go build some stuff.
With inspection time approaching, the pressure's beginning to take its toll.
Every year's a battle. It's just a different battle. It's weather, it's flights, it's material, it's everything. Every year's different. If it was easy, I wouldn't be here.
To make things worse for Carlton, there's not just the work on the wings to manage. 1.5 miles to the west of the station, construction is beginning on what will be the tallest structure in Antarctica, the South Pole Telescope. Built and tested in Texas, the 270-ton frame and 10-meter dish was then dismantled, packed up, and shipped 12,000 miles to the pole. Its location at the end of the Earth will mean the telescope can always be aimed at the southern sky, unaffected by the rotation of the globe. Far away from polluted skies, it'll capture images of the heavens unattainable anywhere else on the planet. Rising 7 stories into the air, it'll be able to detect cosmic microwave background radiation, the faint light signature left by the Big Bang 14 billion years ago, answering questions on the structure of the universe. It'll also reveal previously unseen galaxies, and perhaps unravel the mystery of dark energy, a force some astronomers theorize will cause the universe to rip itself apart. One of the most powerful telescopes ever built, it will literally be able to glimpse both the birth of the universe and its ultimate demise. Back at the main site, the team have more earthly concerns. It's December 2005, and the final construction on the new wings is underway. Carpenters are covering the station in special plastic sheeting to create an extra seal between the heated interiors and the Antarctic temperatures. But even this straightforward task is complicated by the extreme cold.
The staplers are too cold to work. Staplers just keep seeming to freeze up with the temperature. There might be a little grease in there, so we're heating them up because they're slowing us down a bit.
It's just 2 weeks before the inspection team arrives. But it's also midsummer, and in the Antarctic, that means Christmas. To celebrate, the station's crew head outside for an annual race around the world.
No pushing, no shoving, no tripping.
They'll circle the globe, crossing every longitude twice, a distance down here of about 400 meters. It's the last chance for the team to relax before the inspection team arrives. And by then, everything must be in complete working order. In just 3 short years, Jerry Marty, Carlton Walker and their team have built the remaining 3 wings. The final stage of the Amundsen Scott South Pole Station. It's taken 340 tons of steel, 750 high-tech insulation panels, and 60,000 man-hours, all worked at temperatures 30 degrees below freezing. Now they have to face their toughest challenge yet. A plane is on its way to the station. On board are the building inspectors, known as the design team, led by Sandy Singer. They're coming for one reason, and one reason only: to inspect every detail of every job carried out on the new 3 wings. At the South Pole, Jerry Marty is coordinating a last-ditch review to make sure no regulations have been overlooked. The inspection team will stay for 10 days. 10 days that will push everybody to the limit. 10 days known as Hell Week.
Welcome back!
The pleasantries are over. This is the week that we truly don't sleep. There's anxiety, there's tension, there's some stress levels that are definitely visible here this week.
There's always pressure, there's always, you know, what they want to see, what's done, on and on and on.
Jerry and the team know what they're up against. Every occupied portion of the station has already had its Hell Week. But now it's the final hurdle, the last 3 wings. If they fail, the project will be delayed by up to a year at a cost of millions of pounds. The inspectors fan out. Working round the clock, they look for fire and safety violations, electrical code compliance, structural integrity, mechanical problems, even aesthetic issues.
They'll go through it with a fine-tooth comb. They'll look at every single item on the drawings.
It's 2 days into Hell Week. The inspectors, known as the design team, present their initial findings. Sandy Singer chairs the meeting.
I'm responsible for all decision-making leading up to and granting conditional and final occupancy of government facilities in Antarctica.
There's immediate bad news. The design team have already found 75 faults.
Well, as of compiling this document, 75 total items on the list today, broken out by these major subsystems.
One takes the builders completely by surprise. To move supplies into one wing, the team had built a temporary snow ramp, just meant to last the winter. But the design team doesn't see this as sufficient. Their safety regulations require a stairwell at every fire exit.
What you just told me indicates that a ramp is not an acceptable form of egress. Is that correct?
It has to meet the same handrail requirements as a stair.
Fire alarm is not working properly either. There are serious issues with how the steel beams supporting the station have been installed.
Didn't fit it quite perfectly enough for them to put the bolts in. It chose to weld instead.
And a railing is not up to building standards regulations.
I don't believe there's any power to this one. The unit heaters down here, do you know any reason why they'd be turned off?
Yeah, one of the issues I think is just energy.
No, we'll add it to the list.
Mark it up though, because I can mark it up on mine. Okay.
Even electrical and mechanical systems are turning up huge problems.
Lots of issues?
And basically called to be glued on the wall. Yeah. So
Hell Week is taking its toll.
I would say maybe not all.
Gotta work on quality.
No
You
question.
just gotta do it. And not only that, but the architectural finishes this time have dropped, so we haven't really seen a gain.
The team are working as hard as they can, but a lot needs to be repaired.
Re-chisel, re-screw that in, put the lock wherever you want.
The faults would be considered minor on a major construction site anywhere else in the world, but this is the South Pole. And Sandy Singer won't open the station unless they're fixed. She knows that if an emergency arises here, rescue can be literally months away.
Obviously, we're running out of time. We've got about 3 days left. Friday is the day that we want to get conditional occupancy. And we've got about, I'd say, 40 priority 1 items that are still outstanding.
The inspection is even more stressful than the team feared. It's going to go right down to the last day. There are only 48 hours left of Hell Week, and an already tough inspection is about to get even worse.
Let's go around the table, have the design team develop the priority 1 issues.
I guess this is kind of the big one. The vapor barrier is exposed. It is required to be concealed. No exposed vapor barrier in concealed spaces.
The vapor barrier forms a seal between the heated interior and the outdoors. A section in the roof space is exposed. It's flammable, and for safety reasons, it must be covered with a flame-resistant material. The builders set to work fixing the roof, but it takes time the already overstretched team doesn't have. It's an intricate and exacting job. Tensions are beginning to rise.
I'm not willing to move off the position that I've committed to previously with the design team, that I backed up their recommendation that the original design intent should be upheld.
I don't want to reject any
the big picture. And I don't know
any options.
But
Huge issues.
Yes, but if it's so difficult, then it needs to be rejected collectively, and then we can go back to, I feel, the external methods.
He's come up with, I think, some pretty good ideas, but
I can't compromise. I mean, there's only so much. So far, I can compromise. This one's dicey.
Infrared tests also show that heat is escaping from the roof. Sandy and the team head up there for further investigation. What they find is disturbing. The vapor barrier isn't just leaking. Ice is building up under the plastic sheeting fitted just weeks before. Over the winter, this could cause panels to fail, putting lives at risk. A full repair would require replacing an entire length of roof. An enormous job, impossible to complete before winter.
Well, I know that resources in the next few weeks are definitely already overcommitted, but we do have to find room somewhere in that.
The teams reach a compromise. They agree the problem is serious, but not life-threatening. This is one repair that can wait until next season. But throughout the day, the design team find more and more life-threatening faults known as priority ones. With just 24 hours to go, the situation looks bleak.
Okay, here we are. It's the night before. I'm still hearing a lot of new priority ones, and I'm not exactly sure how many of the previous priority ones are still out there. Ones are still, I guess I'd like a count now.
I get 52 from this list.
With 52 priority one failures, for the construction to stand any chance of success, the team must work round the clock.
Good luck. I sincerely mean that. So let's see where we're at tomorrow.
For the first time in 6 years, the construction team look like they'll fail Hell Week. The inspection team will leave the South Pole Station in just 24 hours. If they don't grant approval, the 3 new wings can't be used for a whole year. And approval can only be granted if all Priority 1 issues have been resolved.
24 hours to go, and looks to me like if you do your math, or what I've heard today, is we've got roughly 50 to 55 Priority 1 items. Some of them are fairly labor intensive. Some are going to require materials on site that we're going to have to continue to find and fabricate. The effort tonight is going to be a long one.
We've been given a list of things to correct, and in the process of doing that, we found a few other things. So, yeah, it's a pretty good couple of pages.
Yeah, fix that ceiling. I finished the upstairs handrails, got the threshold done, and I'm in the back doing the cove base. I just need the exterior corners.
The opening of the station will depend on satisfying Sandy Singer and the design team. The construction team worked through all 52 Priority 1 items.
Tim. You were to look and see the 2 gates.
They build a complete fire exit entirely from scratch to replace the snow ramp. Repair electrical lines, mechanical systems, and the fire alarm. They work all through the night. A final push at the end of 3 long years' hard work. It all comes down to the final meeting. It's time for Hell Week to come to an end, one way or another.
At this point, I guess I'd like to go around the table to the members of the design team.
A single Priority 1 failure will mean the 3 new wings can't be occupied, and the station will not be complete for another year.
And cut to make it either shorter or longer.
The design team. Tim, give us a status on your Priority 1 items.
Okay, all of my Priority 1 items have been satisfied. There were...
Well, it's truly amazing. I accept on behalf of the National Science Foundation and the Office of Polar Programs.
It seems the last all-nighter has paid off.
So, conditional occupancy is hereby granted. Congratulations.
The Amundsen Scott South Pole Station is now open for business.
All right, so let's make it official, and I can declare that Hell Week is over. Congratulations.
The team has pulled off an amazing feat of engineering and human endeavor. They've built a polar station that would be home and office for some 150 people. Most importantly, it'll allow scientists to focus on research that may change the very way we see our planet and the universe. For the team, it's an incredible achievement. And for project managers Jerry Marty and Carlton Walker, it's the culmination of nearly a decade's work.
To be part of that team is something that, for me personally, it's completing the loop on a chapter of my life that's been a dream and a goal forever and ever.
Waste battery. Okay, good on you.
Smile! For the last 8 years, we fought it every year to get to this point, and we did, so we're there.
The Amundsen Scott South Pole Station completes a dream begun more than a century ago. The first explorers could never have imagined the scene here today. A landscape dominated by a building that has pushed engineering and technology to the absolute limit. It's a stunning achievement, and a landmark that will help